Okay, first we are going to go over our bell ringer. This is the day 43 bell ringer. First question says, in a DNA molecule, the sides of the letter are composed of. Well, this question, this is the one that will be graded. It goes with the multiple choice down at the bottom. So in the DNA molecule, the sides of the letter are composed of. Remember we looked at that the other day, and we have the rungs are the bases, but connected to those bases are those sugar molecules with that circle phosphate coming off, and then another sugar molecule. So I've got a picture of it in there to show you better. Image. Let's see. You can find. This one's pretty good. Okay. So here in the middle, these are the rungs. Let's turn over sideways this time. So these are the rungs of the ladder. They've got an A bonded with a T, and an A bonded with a T, and a G bonded with a C, and a G bonded with a C, and so on through here. And these are our nitrogenous bases, is what I should say. Nitrogenous bases, and they are held together by hydrogen bonds along the middle there. And then these sides, this is our sugar, this is our deoxyribose, and that's a phosphate group. There's a deoxyribose, there's a phosphate group, deoxyribose, phosphate group. So all up and down the sides, both sides are the sugars and the phosphate. Sugar, phosphate, sugar, phosphate, sugar, phosphate. So that would be the correct answer. There would be the sugars and phosphates. That would be what you will click for the multiple choice question. Then we're going to go back and look at some of the others. I'm not sure why there's a that there. So we'll just copy that. So there's a picture of that. And then it says, when we were just looking at this, it says the sides of the ladder are held together by, well, between this sugar and this phosphate and this sugar and this phosphate and this sugar and this phosphate, those are covalent bonds. So covalent will go in that blank. Those are the stronger bonds. They're sharing of electrons. It is covalent bonds. Our next question says, one side of a DNA molecule reads ATGCCGT. So what would the complementary side read? So we're doing a complementary DNA. So we come right here. Still a DNA. So A is going to bind with the T. T is going to bind with the A. G with the C. C with the G. C with the G. G with the C. And T with an A. That will be our complementary DNA strand. Okay, notice we have 1, 2, 3. That's one triplet right there. 4, 5, 6. That's another triplet right there. And then we have an extra one on here. We have two complete triplets. Remember, it takes a triplet. Triplet would code for what we would call a codon. Those 3 bases there would code for a codon. They would go and pick up an amino acid and bring it to the ribosome to be built into a protein. So it takes 3 bases to be a codon for one amino acid. So this next question says, if there are 27 nucleotides, we have 27 of those bases, how many amino acids will that make? Well, it takes 3 to pick up one amino acid, and that'll be a little clearer next week when we talk more about translation and the tRNA. But just know that it takes 3 of these, 3 bases, to make a code for 1 amino acid. So we got to see how many groups of 3 we have in 27. So 27 divided by 3. And now 27 what you would do would be 27 divided by 3 would equal 9. If 27 divided by 3 equals 9, that means there's 9 sets of 3, 9 triplets, 9 codons in there, so it would code for 9 amino acids. The next one says, how many nucleotides do you need to make 5 amino acids? Well, we just said it takes 3 to pick up 1 amino acid. So if we need to pick up 5 amino acids, we need 3 of those bases to code for each of those amino acids. So 3 times 5 would be 15. So it would take 15 bases, at least 15 bases, to code for 5 amino acids. And that's our Bellringer.